often scares people because these are word problems. But I don't know. I don't know. This chapter, even if the factoring and all the numbers and letters and stuff like that, you're still battling with that, you may find that word problems you can do without having to overthink it too much. Okay, so give it a chance. And if your desk has been moved because of the quizzes and stuff like that so you can't see, feel free to move the desks around wherever you want now. All right, I made up this new example this year because I thought it was fun. My example says, Iron Man jumps out of the Avenger jet and flies near a lake. The graph below shows his height as he flies. And as soon as I say that, somebody should look at this and go, wait a minute. 0, Iron Man goes under 0 height? Does he hit into the ground? That's why I put it near a lake. Iron Man can fly into the lake. No problem. So, a negative height means he has flown underwater. The graph below shows his height over time. His height is measured as meters, and his time is measured in seconds. Doesn't seem to be much to do. So they ask you a question about the situation. I put mine on a separate page. Estimate the height of the plane. Estimate the height of the plane. Apparently, we can get the height of the plane right out of that. Now remember, Iron Man jumped out of a plane, flew, went into the water, came out of the water. How high was he when he was in the plane? 25 is correct. How did he get it? How did he know that that was the height of the plane? He knew one way because he went, okay, between 20 and 30 is 25. Yes, that's one way. But how did he know to look there on the graph? That's where he started. It's the start value. It is the same start value from previous chapters when we did linear. It's just a start value of a parabola instead. So how high? Estimate the height of the plane? 25 meters. Okay, so maybe some of you have got your attention back a little bit because it's not so algebraic here. It's not x's and these numbers multiply to that. You just look at the graph, see if you can answer the question. Next question. How long until Iron Man reached his minimum height? When did he get the lowest he was going to go?
He reached it in 5 seconds.
5 seconds right here. So this is what you should put on here. I usually put a little dashed line going, hey, there it is right there. There's the lowest. Now, if you're looking at your graph and going, no, I think it's a little more than 5. I think it's a little less than 5. Sometimes in the graphs you got to estimate. You got to say, well, it looks like around 5. I'm not going to bust you on it if it's close. So I'm going to say 5 hours, seconds. They told us this particular graph was in seconds, so 5 seconds. Now, how high was the minimum height? What was his height at the 5 second mark? It's a weird answer. -5. You can almost never answer -5, right? Normally heights don't go -5. But Iron Man can because he's flying into the water. So he's gone 5 meters underneath the water. When did he enter the water?
3 seconds.
3 seconds. There it is right there.
7 seconds.
When did he leave the water? Oop, I went the wrong way. There it is, 7 seconds. That's when he came back out of the water. 7 seconds. And then it says, write the vertex of the parabola. I've got the information right there if I wanted it, but what are the coordinates of this point right here? 5. Just 5. 5 over, and then 5 down, -5. So that's the vertex of the parabola. We're 1/3 done already. I don't think that, sometimes in math too, like the second question's way harder, the third question's way harder. I don't think that's really true here. I'm just doing 3 different examples. I just typed these up the other night and went, oh, let's come up with something that they can maybe not relate. I don't know about relating to, but just going, okay, let's talk about Iron Man for a second. It's -5. My thing's just covering, my pen's just covering that. That was a -5. Does my 5 look like an S to you? It's like you could afford to write a little neater there, Mr. Todd. 5. There we go. Happy? We're good? Any questions about those answers on the first one? That's all it is today, word problems. So again, if factoring is still a challenge for you come test day, make sure you at least try in the word problems. Because I think the word problems, you just have to look at the parabola and try to answer the questions about it. Because I'll give you the parabola. Next one. Mr. Todd shoots a pair of shoes out of a cannon. Mismatched shoes, probably. Yeah? The height of the shoes above the ground in meters after t seconds is given by this formula, but I gave you the graph. The graph of this relationship is shown below. See? Shot out a cannon. They went up in the air, and they came back down. Very similar situation to Iron Man, except the shoes went up in the air, Iron Man went downwards. That's all. That's the only difference. So what's the first question? Why does this graph just have one t-intercept? What are they talking about? There's only one t-intercept here. There's not a second t-intercept. Look at. What's that? Because it's on the h. Yeah, because I started off above 0. And since I started off above 0, I only get one t-intercept out of this. I'm going to try and phrase that with a shorter sentence, but that's all that's happening. Because the shoes started above 0. Maybe it's more complicated than that. Maybe it's not. It might just be simple that, oh, you're not going to get a second t-intercept because the shoe started above the ground. They can only hit the ground once in this situation. Iron Man could do the way he was flying. He could hit twice. Not because he's Iron Man, just because of the nature of the situation. How long were the shoes in the air? Oh. Did I photocopy it too small? Does it look like 18? Yeah, 1.8. If you look really closely, and maybe I got to check my photocopies, and I'll put them on there. These are all decimals. 0.1, 0.2, 0.3, 0.4. On my screen, when I press print, I could see that pretty clearly, but it could be by the time it got to your photocopy, it didn't. So I'm going to have to check that and maybe fix that up. But you knew what you were saying. 1.8. Though those are all decimals. So I fixed those on there. You might want to fix it on yours, okay? Where's the questions? How long were the shoes in the air? 1.8 seconds. And what was the shoe's maximum height? What's the highest my shoes got up in the air? Yeah, no, his answer's perfect, actually. That's exactly the way you should be thinking about it. 6, no, well, hang on. Didn't quite get to 6, did they? There's 6. We got above 5. We got to sort of estimate here and sort of go, well, I don't know. 5.2. 5.2. It sort of really looks like 5.2. If you said 5.3, I'm not going to mark it wrong. If you said 5 point something small, I'd be like, yeah, that's about right. Sometimes in graphs, we're stuck with that. We got to estimate sometimes. So I'm even going to write the word, about 5.2 meters. It looks like it's about 5.2 meters. We could argue about it and say maybe it's a little lower, maybe it's a little higher. Now, when did this happen? When did the shoes reach the maximum height? Do we have to estimate there? No, I think it's pretty close to right on a value. It looks like 0.8 seconds. So that one doesn't, I don't feel I have to write about there. But you could write about 0.8, and I wouldn't mark that wrong. And the graph says sometimes it's hard to tell. Oh, toughest question of the day. So if you've drifted off to sleep and you're like, oh, I can do these pretty easily, or maybe you've even snuck up and you're starting to do some of the homework questions, maybe that's what you're working on. Maybe you want to come back for this one, because this is a little bit difficult. How long were they above 3 seconds? Above 3 meters. Okay, so when did they first get to 3 meters? Right about there. Then when did they get back down to 3 meters? Right about there. So that is the time from there to there. But that's not going to be easy to figure out how long that was.
1.3 seconds.
He says it is easy. How did you do it?
Because there were 2 halves on each side, and then I just counted the ones, and then I put in the half.
He's right. He's totally right. He said, don't worry about the halves. He went 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.1, 1.1, 1.2, and 2 halves is 1.3. I like that. I can't argue with that at all. You could take this estimate here and say this is about 1.45 seconds. And this one's about 0.15 seconds, and you could subtract them. But I don't know if that's better than what he said. I'm just saying that's what's going on there. Is you could subtract the 2 time values. And what you said 1.3, right? Yeah, 1.3. And I'm going to write about again, just so you feel safe to know I don't need exact answers here when you're going off a graph. It looks like about 1.3 seconds. The tough part of that was putting the 2 dots on. By the time I put the 2 dots on, maybe you're off the race. You're like, okay, I see. I just got to figure out how much time that was. There. Questions there? What's the next question? Are we almost done this one? Sketch a graph that would represent the shoe's height above the cannon. Ooh, spelling error. You can tell I just typed this up the other night. That's not how you spell cannon. Can you fix it on yours? Cannon has 2 N's. Rather than the height above the ground. Now take a look at this. I'm going to do something funny, I think. I think I can do something weird to show you what I mean by that. Is instead of doing height off the ground, if I was doing height from the cannon, see the cannon starts right there. That would be 0 for the cannon. So watch, I think I've got a cool revealer tool on this that will show what I mean. This is what the graph I want looks like, just height above the cannon, see? That's what I want right there. Just that part, because I'm just how far above the cannon. And then it would go negative. Like, it can go negative? Well, it can go below where the cannon was. So you could think of that as negative if you want. So that's a little bit weird. So here's me drawing that basic graph. You can hand draw it. It's okay. You need something like this. Straight line, and now the parabola would look like this. It would start at 0, and it would go underneath. That's all I wanted there, was just to go, it is possible to get negative height. It just means below where we are. Imagine if I threw something out this window. Wouldn't that be fun if right now, as part of this demo, I just grabbed somebody's phone who's always using it during my lessons? That would be awesome. And I threw it out the window. When it landed down the courtyard there, I could say it was negative height because it went down. So negative height maybe isn't that weird. We won't do too much of it, but I just wanted you to know that it's possible to do negative height without being below the ground, which is below where we were. Yeah? How many intercepts does this have? 2. It's got 2 t-intercepts. And what do these intercepts represent? Where the shoes were level or even, you could use the word even, with the cannon. Wouldn't that be a cool class if right now I wheeled out a cannon out to the window there and shot some shoes out into the courtyard? That would be, actually that'd be physics class. Physics, they don't shoot cannons, but they do start launching things around and using slinkies to study waves and so on, so they really get into it when you take physics, yeah? Okay, do you have any questions about that? Is it the separation of desks, or was it because I got upset with how you acted yesterday? Why is it so quiet? Or was it the quiz? Everybody's like,
It's just the day, I was telling you.
it's the day. Look at it out there. Rain, cold rain. Even snow isn't as depressing as cold rain. Yeah. If it was snowing out there, we'd look out and go, huh, snow. Everybody gets excited. But cold rain, it's jamma day. Go home and get in your jammas. Okay, last question. Let's wrap it up. I don't think question 3 is any harder. I already forget what question 3 is about. Good, now you're talking a little bit. See, I don't need silence. I don't need silence. I need you to listen. I need to think you're out there, okay? Thank you. It's better. Profit, number of cups of lemonade sold. What? The graph above shows the profit for Chloe's lemonade stand. My daughter Chloe runs a lemonade stand. Now, this graph confuses people when they first look at it. Why does her profit do this? I'll tell you why it does this. First of all, Chloe's got to sell some lemonade first to first pay for the cups and the ice and everything. So her first few cups of lemonade don't actually make her any money. She's got to pay for stuff first. Then for a while, she's making lots of money. But then maybe she runs out of cups. And if she sells any more than this, she's going to have to go buy more cups. And now her profit's going to go down because she's going to go buy cups. It's not a perfect graph. It's not a perfect situation. But it gives you an idea of why. She'd like to sell exactly as many cups of lemonade to get maximum profit. Just run out of cups, run out of lemonade, and then go home. She doesn't have to buy more cups. We'll just keep it as simple as that. Okay, so here's the questions. State the vertex. There it is right there. 30, comma, 75. That tells us a lot about the situation. Chloe wants to know all about that point. She knows if she sells exactly 30 cups, she's going to make $75. She'll be very happy. But that's not the question asked. It just said, state the vertex, 30, comma 75. That's where she'd like to aim for. That would be perfect day for Chloe. Then it says state the zeros. Here they are, there and there. 4.5 and 54.5. These are important numbers for Chloe, because if she sells 4.5 cups of lemonade, she'll make zero profit, but at least it won't be negative. You say, well, what's zero? Well, zero's better than negative, let me tell you. Say, how can she sell 4.5? You're right, she can't. At 4 cups, she's still losing money. At 5 cups, she's now making money. Don't overthink 4.5. That just means it's somewhere in between. Yeah? Imagine, okay, let me give you a different example. Let's say your parents give you $10 allowance every week, and you want to save $25 for a new video game. How many weeks does it take? You go, 25 divided by 10 is 2.5. No, it doesn't take 2.5 weeks. That's just a number that helps you understand. It takes 3 weeks. 2.5 was just what it came out to be. Yeah? All right. State the axis of symmetry. Ooh. Here's the axis of symmetry. It's a great warm-up question. See, when I was making up this one, I'm like, start doing the review right now, Mr. Todd. Get a little review on this last question. There's the axis of symmetry. It's at
28.
x equals 30. Do you agree it's 30? I tried to make it right on the number, yeah. State the max or min value. 75. I'm even going to put the dollar sign out there to help you understand what that is. That's the most Chloe can make, is $75. And what's the final question, the first part? State the, quote, y-intercept. Oh. I can't see the y-intercept.
0.
But no, it's down here somewhere. Where do you think it is approximately, the way this is going?
-20.
About -20. Okay, so let's put that down, about -20.
Sorry for the interruption. Can the following students come to the main office now? Brooke Atfield, Rachel Babaka, Bigwan Babari, Peyton Glassfold, Xavier Long Adams, Sydney Natal, Kieran Room, Mailing Seto, Reese Smiley, and Rowan Spriel. Please come to the main office now.
Now, how many cups does she need to break even? I wanted to throw that term in there because if you go into business, break even is an important number. Break even is like, well, I'm not making any money yet, but at least I'm not losing money anymore. So she needs to sell. She needs to get to here to break even. 4.5. But let's just talk. How many cups of lemonade is that?
5 cups.
She needs to sell that 5th cup, right? 5 cups of lemonade. That's the important one. Once she gets to 5 cups, she's not making a lot of money, but at least she's not losing any money anymore. So we call that break even. Have you heard break even before? Yeah? If you haven't, then that's okay. I can be the one to tell you about that thing, that phrase in business. How many cups for maximum profit? What does she really want to get? 30. If she sells no lemonade one day, she goes out on a day like this, rainy, cold, and nobody comes for any lemonade, how much money will she make or lose? We guessed about -20. About -20. That was our guess. We didn't have it on the graph there, but our best guess is it's going to cost her about $20. And then how many lemonades does she need to sell to make $45? Let's go back to the graph. $45, right about here. Oh, that one came out nice. About 14 cups. Okay, well, I'll write 14 cups because maybe you don't think it's about. Are you okay with word problems then? If you just look at the graph and know what you're looking for, maybe you won't find word problems too hard. So don't let that intimidate you. I know that can intimidate people on a test. Like, oh, word problem, I can't do it. That might be true in math, but it's not true this chapter. This chapter, you're like, oh, good, word problem. I just have to look at the graph and figure out the answers.